All right, deep dive time. Looks like we've got a ton of stuff about the moon this time around. Articles, audio, you name it.
Lots of lunar interest.
Yeah, and particularly about its origin. So how to get there, this big old moon, that's what we're diving into.
The big question, and we've got a lot of ground to cover. Theories from, well, ancient Greek philosophers all the way to the latest NASA simulations.
A real journey through time, huh?
Absolutely. It always gets me how the moon, it's right there. We see it all the time, but figuring out how it came to be, that took centuries.
For real. I mean, think about it.
Yeah.
People have been looking up at the moon forever, using it to find their way, figure out the seasons, even worshiping it.
Totally. It's been woven into so many cultures and beliefs. And of course, those early civilizations, they were the ones who started creating those lunar calendars, right? Tracking the phases and all that. They were really paying attention.
Makes sense. Got to keep track of time somehow.
Exactly. And, even way back then, there were folks trying to figure out the how of it all. Like Anaxagoras in ancient Greece, he thought maybe the moon was a giant rock that got flung off from the earth.
Oh, going against the grain back then.
Talk about a bold idea, but still just a theory, right?
Oh, absolutely. Just a theory. But it was a step,
Yeah.
away from the purely mythical and toward trying to explain things based on, well, what could have happened.
Right, right. So I've got these early ideas, but then things really start to change with, well, I'm guessing you're going to say the telescope.
Bingo. 17th century rolls around and bam, telescope changes everything. Suddenly we can see the moon up close, in detail, a whole new level of observation.
And Galileo, he was right there at the forefront. 1609, he points his telescope up and
Yeah.
what a moment.
Game changer. Because what does he see? Not a perfect, smooth sphere like everyone thought. Nope, it's got mountains, valleys, craters, a whole landscape.
A place, not just a thing in the sky.
Precisely. It went from distant object to, well, somewhere you could imagine going, in a way.
Yeah.
Exactly. Which, spoiler alert, we eventually did. But before we get ahead of ourselves and talk moon landings, let's stick with the theories here. So we know what the moon is now, kinda, but how did it get there?
The million-dollar question. Well, scientists, they love a good puzzle. So they started coming up with all sorts of explanations. One early one was the co-accretion theory.
Co-accretion. That's a mouthful. Lay it on me. What's that all about?
Basically, picture the early solar system. It's like this giant cloud of dust and gas, right? And the idea is the Earth and the moon formed side by side from this stuff, gathering material, getting bigger over time, like cosmic buddies.
I can sense on the surface.
Yeah.
Same cloud, same stuff, same time, but I'm sensing a but coming here.
You know it. There's always a but. The problem is the moon's makeup, its composition, it's not quite like Earth's. Specifically, it's low on iron.
That's interesting. You'd think if they formed from the same stuff, they'd be more alike.
Right, like siblings with totally different looks. So co-accretion, it hit a snag.
So back to the drawing board. What else did they come up with?
Well, one idea was the fission theory. Now, this one's a bit more dramatic.
Dramatic, I'm all ears.
Imagine the early Earth spinning crazy fast, like out of control fast.
Yeah.
And then a chunk of it just breaks off, flings out into space, and that's our moon.
Wow. Talk about a spin cycle. Who came up with this one?
George Darwin, son of, you guessed it, Charles Darwin, like father, like son, I guess, when it comes to big ideas.
Huh. It's all in the genes. But did this theory, did it, hold up?
Not really. Turns out the physics just wouldn't work. Earth would have had to be spinning at like impossible speeds for that to happen.
So we're striking out so far. Co-accretion, fission.
Yeah.
The moon's origin story is starting to feel like a real mystery.
It was. So another idea they explored was maybe the moon didn't form near Earth at all. What if it formed somewhere else, way out there, and then just drifted too close?
Like a cosmic wanderer getting snagged by Earth's gravity. The capture theory.
You got it. Intriguing, right? But again, problems capturing something as big as the moon. The odds are, well, astronomical.
So, bunch of theories, each with its own flaws. Sounds like scientists were hitting a wall. What was the next big breakthrough?
Sometimes, to solve a mystery, you need some hard evidence. Enter the Apollo missions. We're talking 1969, humans on the moon. Huge moment in history.
One small step for man, all that.
Exactly. But beyond the symbolism, what did Apollo bring back? Moon rocks. Actual pieces of the moon to study. Talk about a game changer.
Moon rocks. I knew you were going to say that. It's like
Yes.
the ultimate souvenir, right? But I mean, these rocks, they must have been like a gold mine of information for scientists.
Oh, absolutely. Like time capsules going back billions of years. And the data they held, it really pointed toward a new, very dramatic theory, the giant impact theory.
Okay, that name has got my attention. Giant impact. Sounds epic. Tell me everything.
All right, so picture this. The early Earth, super young, still really hot, and then out of nowhere, wham, this Mars-sized object slams right into it.
A Mars-sized object. I'm trying to wrap my head around that.
It's mind-boggling, right? So this impact, it's cataclysmic. Stuff melts, it gets blasted into space, a whole mess.
And out of this chaos, the moon is born.
Exactly. Over time, all that debris orbiting Earth, it cools, clumps together, and eventually forms the moon.
Okay, now that is a story. But how does this explain all the problems with the other theories?
Well, for starters, the moon's low iron content. The thinking is that impactor, its core, was probably iron-rich, and it mostly merged with Earth's core during the collision.
So the moon formed from the lighter stuff that got flung out? Makes sense.
Right, and then there's the whole, did the moon form here or somewhere else question. Well, with the giant impact, it kind of formed from both Earth and this other object.
A blend, almost.
Exactly. So you get some similarities, like with oxygen isotopes. They're like fingerprints suggesting a common origin, but also key differences, like that low iron content.
Okay, now it's all starting to click into place. So the giant impact theory. This is the one, right? The prevailing theory about how the moon came to be.
It is. It fits the evidence we have the best. Of course, science is always evolving, so there are still details being worked out, questions to answer.
Right, always more to learn. But wow, we've already covered a lot of ground here. From ancient ideas to, well, a cosmic smash-up. I need a breather.
Me too. Let's take a break, and then we'll come back and dive into the future of lunar exploration. Lunar bases, missions to Mars, the whole shebang.
Sounds good. We'll be back in a flash. Back for more Moon Talk.
I gotta say, that giant impact theory we talked about, it's just wild to think about, you know? A cosmic crash creating the moon.
Yeah, it kind of puts things in perspective, doesn't it? The universe, it can be a pretty wild place. But the moon story, it doesn't end there. In fact, you could say it's just getting started.
True. We've been talking about the past, but what about the future? Lunar bases, missions to Mars. Things are getting really interesting. Where do we even start? Well, I think it's safe to say that the moon, it's not just some distant object anymore. It's becoming a place we're actually thinking about going to, maybe even staying. For science, resources, maybe even one day, who knows, living there.
Okay, now you've got my attention. Lunar bases. What are we talking about here? Like a full-blown moon village with people walking around in those spacesuits?
Maybe not walking exactly. The gravity's different there. But yeah, the vision is ambitious. Think more like a research station permanently on the moon. For science, testing new technologies, maybe even a starting point for missions further out.
Like a stepping stone to the rest of the solar system. I've heard that about the moon and missions to Mars.
Yeah, exactly. Launching from the moon, it has some advantages. Lower gravity means you need less fuel to get going, and there might be resources we can use right there on the moon. Water ice, for example.
So instead of bringing everything from Earth, we could use what's already there. That's pretty smart. What kind of resources are we talking about?
Well, like I said, water ice. They think there might be some in those craters at the poles that are always in shadow.
Okay.
And water, you can break it down into hydrogen and oxygen, and guess what? Rocket fuel.
Ah, so moon bases could be like refueling stations. What else is there?
There's this stuff called helium-3. It's rare here on Earth, but abundant on the moon. And it could be used for fusion reactors. Imagine that.
Helium-3 fusion. It sounds pretty futuristic.
It is, but it's something scientists are seriously looking into.
Cool. And I'm guessing a base on the moon would be amazing for science, too?
Oh, totally. Think about it. Telescopes on the far side of the moon, no light pollution from Earth. It'd be an astronomer's dream.
Wow, a perfect view of the universe. That's incredible. But hold on, let's talk about actually living on the moon. That can't be easy, right?
No, it's definitely not a walk in the park. The moon, it's a harsh environment. Extreme temperatures, radiation, no air to breathe.
Right. You can't exactly step outside for a stroll.
Nope. We're talking advanced life support systems, radiation shielding, maybe even ways to grow food in lunar soil. It's a huge challenge.
A self-sustaining environment on the moon.
Mm.
It sounds like science fiction. Are people actually working on this stuff?
Oh, yeah. NASA's Artemis program, for example, that's a big step toward a sustainable presence on the moon.
So this isn't just talk, it's actually happening. It's pretty exciting. But I have to admit, it's also a bit overwhelming. All these challenges, it seems almost impossible.
I hear you. It's definitely a huge undertaking. But remember, we've pulled off things that seemed impossible before. The Apollo missions. Landing on the moon back then, with the tech they had, that was huge.
Good point. If we did that, maybe we can do this too. But let's step back for a second. Why is all this so important? I mean, it's cool, but what's the bigger picture?
That's a good question. And honestly, it's a question each of us should think about. It's easy to get caught up in the excitement, but exploring the moon, it's about more than just science and tech. It's about pushing our boundaries, understanding our place in the universe. Maybe even making sure humanity has a future.
It's like that drive to explore that's always been part of us, to see what's out there, to push further.
Exactly. And remember, landing on the moon, it used to be science fiction. Now we're talking about living there. It's pretty amazing what humans can do.
It really is. It makes you wonder what the next 50 years will bring. What do you think?
Well, I'm no fortune teller, but I think we're at the start of a whole new chapter in space exploration. Maybe we'll see that lunar base become a reality, new technologies we can't even imagine yet.
Hmm.
Maybe even, who knows, the first humans on Mars launched from the moon.
Wow. It's almost too much to think about. But before we start packing for Mars, let's get back to those moon rocks.
Good idea. Back to the evidence.
Right. Next time, we'll dive into those Apollo samples, see what secrets they hold. It's like a window into the moon's past and the early solar system.
Can't wait. It's going to be fascinating.
All right, back for the final part of our lunar deep dive. We've covered some pretty mind-blowing stuff. Ancient theories, a giant impact, lunar bases. But I gotta say, I'm really excited to get into some, well, actual evidence from the moon.
I get it. Theories are great, but there's something special about those moon rocks brought back by the Apollo missions. I mean, actual pieces of the moon holding secrets from billions of years ago.
Exactly. Those Apollo astronauts, they weren't just explorers, they were like lunar detectives, bringing back clues to solve the moon's mysteries.
Perfect analogy. And those moon rocks, they haven't disappointed. They've given us incredible insights into the moon's formation, the early solar system, the whole shebang.
All right, I'm ready for my crash course in moon rocks. What can they tell us? Where do we even begin?
Well, let's start with what they're made of. One of the first things that jumped out at scientists was how much basalt they found.
Basalt.
Ah.
Right, that's a type of rock. Volcanic, if I remember correctly.
You got it. And finding it on the moon, well, that was a pretty big deal. It told us that volcanoes, they played a major role in the moon's early history.
Volcanoes on the moon. Huh. Always thought of it as a pretty quiet, dead place.
Yeah, that was the assumption before we got our hands on these rocks. But the basalt, along with other evidence, it painted a much more, well, fiery picture.
So, what kind of volcanoes are we talking about here? Like the ones we see on Earth today?
Think bigger. The evidence points to a massive molten lava ocean, like covering a huge chunk of the moon's surface early on.
Whoa, a lava ocean. That's hard to even imagine.
Right, a moon covered in molten rock. But that's what the rocks tell us. And eventually, over billions of years, it all cooled and solidified, forming the lunar crust we see today.
Okay, that is seriously wild. A lava ocean. So where did all that lava come from in the first place?
Well, remember our friend the giant impact theory? That collision?
Of course.
Huh,
That Mars-sized object slamming into Earth.
that's the one. Well, the heat from that impact, it would have been insane, enough to melt the outer layers of both Earth and the impactor. And that molten material blasted into space, that's what formed the moon, covered in this magma ocean.
So the moon wasn't just born from a collision. It was born from fire. That's incredible. But what about the other features on the moon? All those craters and mountains?
Ah, good question. Remember those breccias we talked about? The rocks formed from all sorts of jumbled up debris during asteroid impacts?
Yeah. Those were the ones that sounded like a real mix of lunar material all smashed together.
Exactly. Well, those breccias, along with all those craters, they tell us that the moon's been getting hit by asteroids and meteoroids for, well, pretty much its whole life.
So the moon's been like a cosmic punching bag all this time.
Pretty much.
Hmm.
And those impacts, they haven't just made craters, they've helped shape the lunar landscape, forming mountains, valleys, and those big dark plains we call Maria.
Maria. I've definitely heard that term before. What are they exactly?
Those dark, flat areas you see on the moon, they're actually ancient lava flows that filled in huge impact basins.
Ah, so they were formed by impacts, but then filled with lava.
Exactly. So you've got these internal forces like volcanoes and external forces like impacts all shaping the moon over billions of years.
It's amazing how much information scientists can get from just studying these rocks.
It really is. It's like piecing together a giant puzzle. And you know what? The more we study these lunar samples, the more the giant impact theory is supported. It really seems to fit the evidence.
So mystery solved, right?
Mhm.
We know how the moon got there. End of story.
Well, and not quite. There are always more questions to ask, more details to figure out. That's the beauty of science. It's always evolving. Like, we're still not entirely sure about the exact composition of the moon's deep interior.
Always more to discover. That's what
Yeah.
makes it so exciting. It's like every answer just leads to more questions.
That's a great way to put it. And with all the new missions planned, new technologies being developed, who knows what we'll find out next,
Maybe we'll even find evidence of life on the moon. Now that would be a story.
wouldn't it? But even if we don't find any little green men up there, every new piece of information we get brings us closer to understanding, well, our place in the universe.
And that's what it's all about, right? Exploring, learning, pushing the boundaries of what we know.
Couldn't have said it better myself. It's been a blast diving into all this with you.
Same here. And to everyone listening, thanks for joining us on this lunar adventure. We've covered a lot of ground, from ancient myths to the future of exploration, and it's all thanks to that amazing, mysterious object hanging in our sky, the moon. So next time you look up at it, remember all the secrets it holds, all the stories it has to tell, and who knows, maybe one day you'll even get to visit it yourself. Until then, keep exploring, keep asking questions, and keep looking up.